Today we're going to learn how to graph using the first and second derivative. Our main function here shown is f equals x squared plus x minus 2. The function is a very basic quadratic, but we can easily graph it using calculus. First, we need to find out the x and y intercepts of the function. This will be quite easy since it's a quadratic, and we can easily factor. So, x plus 2 parentheses x minus 1 will give us that our x-intercepts are x equals to negative 2 and x equals to 1. Our y-intercepts are fairly easy. We just plug in a 0 into both the x's, and that will give us negative 2. So let's write out these intercepts. Negative 2, 0, and 1, 0. Now, we must use the first derivative in order to find our critical numbers. So let's take the derivative. Using the power rule, we take the 2x in front plus 1. That is our first derivative. Now, what we need is to solve for the critical numbers of the equation. So we make it equal to 0, and it'll give us 2x equals to negative 1, and x equals to negative 1/2. That is our critical number, and in this case, our only critical number. Now, in order to be sure what this critical number means exactly, we need to do a chart. So we put the number negative 1/2, and on both sides of put a number greater than and less than. So in order to make our life easier, I'm going to use 0 and negative 1. We now plug in 0 into our derivative. It'll give us a positive number. So we put positive and an arrow pointing up. What this means is that our derivative is positive, and thus our equation is, or how should I say, increasing at the moment. If we plug in negative 1, it'll give us negative 2 plus 1, which in turn is a negative number. So we put a negative symbol and an arrow going down. What we deduce from this information is then that intervals are from negative infinity to negative 1/2 for decreasing, and our intervals are from negative 1/2 to infinity. So let's clean the board up a bit. Now, knowing that negative 1/2 is a point where the graph goes from decreasing to increasing, we can deduce that negative 1/2 is a minimum number, or a relative minimum of the function. So we write here relative minimum is negative 1/2 and we can now find our y value. If we plug in negative 1/2 into the original equation, since it's on the original function, it'll give us, I believe, 1/4 minus 4. I'm changing it so we have the same denominator, since 2/4 same as 1/2, minus 8/4. Just simply reducing this, it'll be negative 9 over 4, which is about 2¼ Yeah. So let's clean up the board a little bit. Now that we have found a relative minimum, let's use the second derivative in order to see what we can do from there. The second derivative of this function is f double prime of x equals 2, basic power rule equals to 2. Now, our possible inflection point is not 2, because 2 is not a value that x is equal to. So what does this 2 mean exactly? What we know from definitions is that f double prime of x, when it is greater than 0, means that the function is concave up. That is what we know from our definitions. So, using this rule of concavity, our f double prime of x is equal to 2. And as far as I know, 2 is greater than 0. So, our function will be concave up all throughout, from negative infinity to infinity, because this quadratic function does not change concavity at any given point. It does not have any point of inflection or a possible point of inflection. So now, given all this information, let's see what we can graph out. If we clean up the board a little bit, and we just quickly insert this graph, now that we have our axes at the back, let's try to graph out what we have. So let's start out with our intercepts. -2, 0, and 1, 0. Now let's do the -2, 0, or the 0, -2, sorry. And from what we know that at -1/2, our function will be at the point -9/4, and it'll be a minimum. -9/4 is 2 2/4, so just moving down, it'll be right about there. And that is all the information we have, except for our intervals for increasing and decreasing. So let's use this color in order to stand out a little bit, and let's start putting in what we know. So from -1/2 to infinity, the graph will be increasing. So that'll be something like this in that sense. And it is decreasing from negative infinity to negative 1/2. So it'll probably come down and meet right there. Let's just accentuate that little point right there.